So this is the second update today for the Prusa Mendel 3D printer project. I'm just cataloging all the changes that I've made to the printer to try and make it more reliable and work better. I talked in the last video about how I re-engineered the bed to make it flat and less prone to warpage. In this video I want to talk about the extruder and hot end. I've completely redone the extruder and hot end and replaced them with different technology. And so basically the problem with the old hot end was, well, I had another hot end come apart on me. So this is the old hot end, and you can see the PTFE barrier has separated from the brass nozzle piece, and you can actually see there's a filament shooting out the side. I was also having trouble with the Wade's extruder feeding reliably. Part of the problem with this is I didn't probably assemble it correctly. There were no instructions with this. You got a bag of parts basically, and you're kind of left to figure out how to put it together. There were no instructions on the web that I could find, and maybe they're out there, but I couldn't find them. So you just kind of had to figure out how to put it together. Turns out there's a plastic barrier that, with some threaded rods, the plastic retainer goes on the bottom of the nozzle and pulls the nozzle and the PTFE barrier together. I didn't have that installed, so I'm sure that's why this came apart. But bottom line is I never got this to work very reliably, and then it fell apart. Also, had trouble with the Wade's extruder feeding reliably, so I ordered like a commercial hobbed bolt because I thought maybe the hobbed bolt that I had wasn't right. There again, though, it's kind of an issue of, I got parts from all over the place from different suppliers, and putting them all together and making them work well together, I think was the biggest issue. Probably the biggest issue was the springs that I was using weren't the right kind, didn't have the right tension or something along those lines. But the bottom line is I never got it to work very reliably. So I decided to kind of make a change, go to the Maker Gear extruder, which is on the system now. So the Maker Gear extruder, the difference between it and Wade's, it uses this geared stepper motor rather than a stepper motor with two plastic gears. It's actually an engineered gear motor basically, and instead of using a hobbed bolt, it actually uses a commercially machined gear. So there's still a 608 skate bearing for the idler block, and that's running against a machined gear on a shaft coming out of that gear motor, and that pinched between that is the filament, which is getting pulled down into the hot end. So since I was making a change, I decided to go ahead and go with the newer technology on the filament and the nozzle. So this filament is thinner than the old filament. It's a 1.75 millimeter filament, and then the nozzle is it's a Maker Gear hot end, and it is the old nozzle was 0.5 millimeters. This is 0.35 millimeters. So it's a smaller nozzle size. The upshot of that is better resolution because it's a smaller bead coming out of the bead of molten plastic coming out of the nozzle. And so the nozzle is different too. It doesn't use power resistor for the heater. It uses nichrome wire. So there's a threaded brass rod in the center, threaded brass tube really, that the filament comes down. There's a heater section that's wrapped in nichrome wire, and then the nichrome wire is protected by a ceramic putty. And then there's a nozzle that threads on, and you can switch out the nozzle to different sizes. And there's a 0.35 millimeter nozzle on there as well at this point. And there's a hybrid transition zone that's made out of ABS plastic, I believe, or it looks like ABS. And then there's like a peak inner section and then a PTF section inside of that. And there's a groove inside the ABS that you can see here. So there is a groove right here, and that groove slots into this piece of wood here, and that's what holds the whole business in place. So it's a groove mounted, and nice positive mounting system, easy mounting system, very straightforward. Really nice thing about the Maker Gear stuff is there's instructions on the web with photographs on how to put everything together. Really straightforward. Everything went together really nice. So I got it all put together, but I was having trouble with the PLA jamming in the extruder. What would happen is, I would feed like 100 millimeters to calibrate the extruder, and that would feed fine, and then I'd go back to feed another 100 millimeters and it would jam up, and I would open up the idler block, and I'd find a big mess of PLA jammed up inside the extruder. And this became a real problem, actually. It became my white whale. I spent a lot of time trying to figure out what was causing it, and Rick Pollock, the engineer from Maker Gear, told me that the largest issue he saw with jamming and PLA was related to the temperature. So the temperature is measured on the nozzle by a 100K thermistor, glass bead thermistor, that's taped to the nozzle with Captain tape. So I said, well, let's verify that we're getting the correct configuration in the Sprinter firmware for the thermistor value. So there's tables in the Sprinter firmware, and you select the right table for your thermistor, and then you should be getting accurate temperature measurement, but perhaps I wasn't. So I've got a multimeter that measures temperature, and it's got a glass bead thermistor that it uses for temperature measurement. So what I did was I attached both thermistors, the printer thermistor and the one from the multimeter, so I could compare the temperatures and see which one was correct. And what I found was when I set the temperature to 185 degrees Celsius, which is the recommended printing temperature for PLA plastic, it was actually measuring between 195 and 205. So that wasn't quite right. So I downloaded the latest version of Sprinter. I was using the #1 resistor table, which should have been the correct table, but it wasn't quite measuring correctly. And I noticed in the new Sprinter firmware, the latest version, there are more values available for 100K thermistors. So I tried each one of the values for 100K thermistor, or each one of the temperature tables, and found that in my case, number 7 worked most reliably, or most accurately, I should say, in terms of measuring temperature. So 185 degrees Celsius, set on the printer would match on the multimeter. So once I got that sorted, I thought, aha, I've solved the issue. But no, I was still having trouble with the printer jamming. Tried different temperatures. I tried printing PLA at 165 degrees centigrade, 170, 175, 180, 185, 190, 195, and so on. Didn't matter what I set the temperature to, I'd still get jamming. So I was kind of like trying to think of things to try. I tried this 40 millimeter fan for the nozzle, so that cools the filament as it comes out of the nozzle. Really shouldn't have anything to do with jamming. I don't know why I thought it would fix it, but I tried adding the fan. It's a good thing to have anyway. It cools the filament as it comes out of the nozzle, causing it to harden quicker, which is great like if you're trying to span a gap. So for example, on this whistle, on the flat, when it gets to the top, it has to span a gap across it. The fan helps it do that because it freezes the filament in place by cooling it as it goes across that gap. So that's a good thing to have anyway. So I added that 40 millimeter fan. That didn't solve the issue. I added a new spool. This is it's a spool for a extension cord that I got at Ace Hardware for like 15 bucks. Works really good as a filament spool. So I'm using that for the filament spool. That didn't make any real difference with the jamming though. It's nice, works out well as a spool. So then I tried, I saw on Notped's website, he was talking about having trouble feeding PLC plastic, and he was using a little felt wheel such as this to feed the filament through. To clean the filament, lubricate the filament, put a couple drops of 3-in-1 oil on the felt wheel. That's actually a felt polishing wheel from a Dremel with a hole in the center, and the filament is going through that. You can see it's being held onto the top of the printer by a bulldog clip, and that works pretty well because it can kind of slide back and forth a little bit on the printer as the x-axis is moving side to side. And you can see that not only does it clean the filament, but it also has lubricates the filament, and then gives it a nice angle going into the extruder. So so that works out pretty well. But that didn't solve my jamming issue. So you know, it seemed like no matter what I tried, I was still getting the jamming issue, and that was really frustrating. One of the things I was trying to do is I was trying to print out Gossamer's parametric TARDIS, and it's a TARDIS, which is, you know, Doctor Who's time vehicle from the Doctor Who show. And one reason why I was using it is because it's like 5 inches tall. So I thought, man, if I can get through this whole print, then I've got a reliable extruder. And this is about how far I would usually get. They would print out the base, and then it would jam. I got a bunch of these laying around now, so I don't know what I'm using them for, but I got a bunch of these. The PLA I'm using is silver in color. So this is a silver PLA, and this is usually, you know, it would just jam up and not work. So I was kind of at my wit's end, and I wasn't really sure how to fix the issue. And I was just kind of sitting, staring at the printer dumbly, like trying to figure out what to do. And I had accidentally left the printer on overnight, so it was connected and powered on, and so the stepper motors were hot. And this stepper motor was really hot. This is the stepper motor that, of course, drives the gear for the filament drive. This is all metal, so the heat was passing through here. So on a hunch, I pulled the idler block off, and the gear inside there was actually hot to the touch. I mean, hot enough that you wouldn't want to leave your finger on it. And I thought, I wonder if the heat is passing from the stepper motor through the metal housing and metal gears to the shaft and into the gear, and causing deformation of the PLA before it even gets to the hot end, and causing it perhaps to even stick to the gear and cause the jamming issue that I'm seeing. So I put a fan on it. Now originally I've added a second 40mm fan, and you can see I've added it to the top of it, and I've epoxied it on here. Originally I super glued it onto the end of the stepper motor, and that worked fine, but then I realized I'm losing some X travel because the fan's going to run into the side of the this Z-axis mount. So I said, well, let me move it to the top. But I tested it out here with super glue, and it worked fine. In fact, I basically got all the way through the TARDIS, and basically that fixed it. I mean, that was the fix. So the upshot is it's now working reliably. I'm very happy with the print quality that I'm getting. You can see here the print quality is quite good. I'm the proud owner of a new TARDIS, and we put a little blue LED on the top here, painted up blue, and put that in my Christmas village. But that did the trick. That was the issue. That was the root cause that was causing all my problems with feeding the filament. So I recommend, if you have Maker Gear extruder like this, add a 40mm fan, and you can just epoxy it. I used 5-minute epoxy, epoxied it right to the stepper motor. And also what I did was I added in a couple of push button switches for the fans so that I can turn them off and on. And so I wanted to be able to turn off the nozzle fan when it's printing the bottom layers, so it allows those bottom layers to stick better. So I print about 3 or 4 layers, and then I hit the push button and turn the nozzle fan on. And these are labeled NF for nozzle fan and EF for extruder fan. But I can control those separately with these push buttons and turn the fans on or off. So it's working very reliably now. I'm not having any trouble, and I'm very happy with the results. So hopefully, if you're embarking on a project such as this, you can learn a little bit from all of the troubleshooting that I did, and end up at a better result to start with. So I do recommend the Maker Gear extruder and the hot end, but I also definitely recommend you add the fan to the stepper motor, and I think you'll have good results. One thing I should say about the stepper motors is there's a driver that drives these stepper motors, and my driver you can change the the amount of power going to the stepper motor with a set screw on the driver, and I had mine set to 25%, so I couldn't really see lowering the power to the stepper motor. I don't think that was the issue. I think the issue was that it was just getting hot. So that was the fix, and I think that's it for now. Now I can get back to deciding what I want to print with my printer. I printed out a little whistle with the P inside, so the P's inside the whistle, and it works. And I printed out my TARDIS, and I'm going to print out more stuff, but I can get down to the serious business of trying to print out gears and parts and things like that now that I know the printer's going to work reliably for me. So probably one of the first things I'll do is try to print out a complete set of parts now that the printer's working for spares, so another set of Prusa Mendel parts. There's some alternative parts. There's different Z-axis couplers that you can get that Knop had designed. There's a gear that is concave, so that it's self-centering, so that it lines this belt up in the center of the pulley. Probably want to print a set of those out. There's also X and Y axes that use either bronze oilite bushings, which probably would be better than the printed PLA bushings. And then there's also one for a set of inexpensive linear rails that you can get. That might be an interesting project too. But now I can get down to that kind of serious business of printing out parts and stuff that I wanted to get to when I started this project. So I guess that's pretty much 3D printing in a nutshell. 1 month to build a machine, and another 5 months to work all the kinks out. But I'm very happy that it's working reliably now, and I'm getting very good print quality. Another thing that I'm going to be working on is NetFab. NetFab is a piece of commercial software, skinning software, that does the same thing that SkyForge does, but it's a commercial variant. I've seen some of the prints that people are getting from it on the web, and the quality looks pretty amazing actually. So I've got a copy of that. I want to learn how to use it, learn how to print with it. Getting good results out of SkyForge, so nothing against SkyForge, just I want to see if I can improve the print quality using NetFab. So the next thing is probably to learn how to use NetFab and learn how it works. And so I'll give another update once I figure out NetFab and how that's working. So that's it for now. Thanks for watching this video, and more updates later.